Alright, Unit 9, Notes 5, dividing rational expressions, learning target, I can divide rational expressions. So we've been multiplying in the last notes video. You took a quiz on it. So hopefully this should be something easy for you to do, because look at this. Dividing rational expressions is the same as dividing fractions. You are multiplying by the reciprocal, which to me was copy dot flip. That's one trick to remember it. But you got to flip the second expression and multiply. So what I'm looking at is this, copy. So copy would be 5x squared over 7. Dot, multiplication symbol, flip. It becomes 21 over 10x cubed. So that's really all you're doing. Now you're supposed to be good at multiplying. So I like to reduce the 7 to a 1. That reduce the 21 to a 3. 5 would become a 1. So I could have a 2. And then I'm looking at these 3 and these 2. To me, there's just one more in the bottom. So on the top, we are going to be left with 1 times 3, which is 3. These are going to go away because I'm going to have an x left on the bottom and 1 times 2. So I got 3 over 2x. Now we also got to do our excluded values little chart here, and x cannot equal 0. Okay, so when we look for these on your test, I usually give you a point for this, or 2 points for getting the right answer, 1 point for knowing the excluded values. So this is the same thing. Copy. I like copy dot flip myself. I don't really care how you remember to do it, as long as you know division becomes multiplication. So 27c3d squared over 11d times, and then I flip it, 9de, this is 3 over 2c3. Bad news. 11 and 2 are prime numbers. 27 and 9 don't have 11 or 2 in them. So one thing you could do is just go 27 times 9. 27 times 9 is going to be 243, alright, over 22. So now I look at my C3s. If I look at these C3s, there's an even number on top and bottom. They're canceling out. Now it looks like I have 2 and 3D. So 2 and 3 is going to become 5. So I might write a 5 here and scribble this one out. But 5 minus this 1 on the bottom, I'm thinking d to the 4th power. And then it looks like I still have an e no matter what I do. So that's what I'm looking for you to be able to do with like terms or the monomials. But we also need excluded values. And now excluded values are anything that spent some time in the denominator. So d definitely did. So I would say d can't equal 0. E can't equal 0. And if you look at it, look at this right here. C is in the denominator. So C cannot equal 0 as well. So this one actually had an excluded value of all 3 of them. So just make sure if they spend any time in the denominator, those are the excluded values. Might simplify nicely, but you still need to do that correctly. So looking at this one, this is going to be a fun one. Alright, b plus 4 over 2b plus 2 times b plus 1 over b plus 12, 3b plus 12. Now looking at this, I'm pretty good at math, and I recognize that this one has a 2 in it, so I'll underline it twice, and this one looks like I have a 3 that I could take out, because 2 and 3 are GCS in our denominators. So what I would do here is I'd rewrite it. b plus 4 over 2. If I divide that first term by 2, I have b. So this is what I'm doing. I'm taking a 2 out. Maybe I'll write in a different color. Divide by 2, divide by 2. Okay, and b plus 1. Times b plus 1 still over. Now I'm going to take a 3 out. So dividing this by 3 would be a b left in the middle. 12 divided by 3 is 4. Now the reason for that is I can look at what cancels out. So I have this b plus 4 here. I think red works pretty well. B plus 4 will cancel with this b plus 4. B plus 1 will cancel with this b plus 1. Now, very carefully, you need to know that even though everything canceled out, division of things is 1. Alright, 5 divided by 5 is 1. So just because it cancels out on top and bottom does not mean it's 0. Alright, so like if I had 5 divided by 5, that's 1. So, however, on the bottom you still have 2 times 3, so I think the best answer here is 1/6. Excluded values. I think B cannot equal, because that's my only variable. Alright, so I look at this one right here. I get that -1. Alright, this one right here is actually the value, since it's 2b plus 2, is actually this b plus 1. So we got that one. But I need this one right here, which is a -4, because if b plus 1 equals 0, that's how I get the -1. B equals -1. And if b plus 4 equals 0, subtract the 4, subtract the 4. B equals -4. So I got -1 and -4. In this one on the bottom, I'll do it in a couple different steps. I'll do my copy, dot flip here. Alright, I'm thinking some 3's are in order. Ooh, maybe a 6, I guess. Times B plus 5. So this is where I flip it. Now, knowing what I know now, I like the 6 right away because that's b minus 2. Then, alright, we also have a 3 because I could write that as b plus 5. Okay, times, I like that because b plus 5 I see is on the top. Over, I have to say 2 times a b plus 9. We're looking at these two. This is a b plus 5, and this is a b plus 5. And that's about it. So I'd probably have 6 times b minus 2 over 3 times 2 is 6 over b plus 9. So I actually missed 3 times 2 as being 6. So I'll just rewrite it like this. Then I'll write excluded values. B cannot equal. Well, let's find them. B plus 9. So what would equal 0 with 9? I would say -9. So B cannot equal -9. Alright, what else we got? We got b plus 5 here. So this was b plus 5. So I'm going to need to minus 5 to each side. So B cannot equal -5. And actually, this is the same thing. Alright, they ended up canceling. That's why I know that we are done with just 2 excluded values. But it's always good to check. Alright, 4 more. So hang with me. Now, we told you there's going to be factoring. Alright, so if you look at that, I have a 3 and a 2. Alright, you should see 2 times 1 is 2, which is the top. Multiply to get the top, add to get the bottom. So I actually know that this is going to be x plus 2, x plus 1, because the coefficient in the a there, this is the a value, because the a value is 1, it's just going to be my x method stuff. So, then I'm going to have that over 4. Now I also need to copy, dot, and then flip that. And for some reason, I've always done parentheses around them, which you don't need to do. So x plus 2 and x plus 2, x plus 1, and x plus 1. Those do not cancel out. Those are in the numerator together. So actually, x plus 1 times x plus 1 is x plus 1 squared over 4. This is my final answer. And then, I need my excluded values for a point. X cannot equal 4 is in the numerator. That's good. I don't have to worry about that. X plus 1. So if x plus 1 equals 0, I subtract 1 to each side. That's going to be -1. And then I got this x plus 2 here in the denominator, so negative 1 or negative 2. So those would be my values for a point. Number 6. Number 6 is a great problem, because number 6, this right here, is a perfect square root example. X squared has a 1 in front of it, so 1x squared, if I take the square root of that, is just x. If I take the square root of 4, it is 2. What that tells you is that you are supposed to know that that top numerator is x plus 2, x minus 2. Because technically the square root of 4 is plus or minus 2, so you always have 2 answers. So that's over 5x, copy dot flip, times x over x minus 2. This isn't too bad of a problem. X minus 2's cancel. X's cancel here. I see, I was going to write the 5 in the numerator. I see x plus 2, x plus 2 over 5 as my simplified rational expression, and I got excluded values. X cannot equal 0 for this one. X is a positive 2, because 2 minus 2 is 0. And looking at what I started with, those are just 0 as well, so I got 0 and 2. So checking all of them that spent any time in the denominator is a good thing to be able to do. Alright, 5 and 6, 7 and 8. Alright, so these are hodgepodge stuff. Looking at this first one, I would see that this middle is 11 and 18. 9 and 2 multiplied by 18, add to be 11. Alright, this one here would have been, here I'll do it in a different color for you, so you know why is this a 6 and a 5? Well, 6 times 1 is 6. 6 times plus 1 is 7. So I'd actually have to go to 2 and 3. 2 plus 3 is 6. Multiply together to get 6. 2 plus 3 is 5. I think I said that wrong. Either way, I would pick up the marker. Uh-oh. I made it think. Alright, so 2 times, I would actually divide both these by 2, because 4 divided by 2 is x plus 2. That is the best simplified version. Now, since this a is 1 here, I have enough information to know that this is x plus 2 times x plus 9. I don't have to do all that grouping stuff that we taught you in Unit 4 if the a value or the coefficient for a is 1, times, so we're going to flip that. So that's going to become x plus 2 on top times an x plus 3. So this would actually be the x plus 2, x plus 3 part that I wrote in the numerator, all over x plus 1. When I do that, not a whole lot of stuff cancels. Probably get rid of this x plus 2 in this one, and that's all I see. So I'd probably write this as 2 times x plus 2, x plus 3, all over x plus 9 times x plus 1. With excluded values being x cannot equal, well, let's look at them. So right here I had x plus 2, so I know that's going to be a negative 2. X plus 9 is going to be a negative 9. Right, x plus 2 equals 0, subtract 2, that's how I get x equals negative 2. So 9, a positive 9 is going to be minusing 9, so that's how you get a minus 9. This x plus 3 was originally, right here I'm making a star, if we look at the original problem, was originally in the denominator over there, so I would add a negative 3, and I would have had this negative 1 here as well. This x plus 2 here is actually taken care of in the first one here that I have scribbled out in black. So those are my excluded values, and I would be done with this problem. So that one didn't really simplify like our other one. You need to have confidence, know you're doing stuff right, not erase it, not make a fuss about it. right? You just need to know that is correct. This last one here, so I hit extend page there, so you might have to go back if you weren't done with that other problem. But I need a little bit of room here. Alright, this top one is a positive 1 and a negative 2. So this is going to be a negative 1 times a 2. Alright, this one here, I would have said, this is 6 and 5. This is from our other one we had earlier, 2 and 3. This one, I'm going to have a negative 3 on top and a 2. Well, I know it's 1 and 3. It's just I need a positive 2, so a negative 1 has to be there. And then last but not least, my last one in blue is going to be 12 and 7, which I conveniently find 3 and 4. So what I probably would want to do is all these, the a value is 1 here. So actually, my x method is good enough to write x minus 1 times x plus 2. Alright, then we could write over x plus 2, x plus 3. Now I'm going to actually switch this up. I'm going to write dot, so it's multiplication, and I'm going to put the denominator in blue there in the numerator now. And then I could see that this last one is x minus 1, x plus 3. So I got the x method here on the left, right? This is supposed to help you out. Figure out how to rewrite those, how to reduce those. We did factoring before. Quick shortcut, x method, boom, there's your answers. Now, with that being said, now I can divide a few things. So this x minus 1 here, I would have put with this one. X plus 2 here, I would have went there. X plus 3 here actually goes here. I actually just end up with an x plus 4 over x plus 3. So this one reduced well for me. I gotta do my excluded values, so x cannot equal. I see negative 3 right in front of me. I think yellow shows up. So that negative 3 is taken care of. I got an x minus 1 there, so I'm going to write a 1. Ooh, this negative 3 is fine. So I need a 1 and a negative 2. So I'm going to go back, make this a 1. I need a negative 2 and a negative 4. Because guess what? This numerator right here was in the denominator at the beginning in blue. So you need to have negative 3, 1, negative 2, negative 3. If you're missing one or something on the test, I'm going to take off a half a point. You got to recognize what was in the denominator before you flip it. Alright, so let's try some application problems with this stuff. And it's not too difficult. A lot of you guys have had physics by now. So rate times time equals distance. So rate times time equals distance. Well, it says what was the average speed. So I'm finding rate. It says distance is miles, 200 days. So I actually want the rate, so I'm going to divide by time here. Rate equals distance divided by time, which is equal to 46,000 divided by 200. So that's cool. Rate is going to equal 2,330,000. So this is miles over days. Miles per day. So that's 2 million miles per day, roughly. Nearest mile per hour. So when I think of that, I got to get rid of this day. So to get rid of the day, I need day on top. Because then day cancels out with day. There you go. Now, I know that there's one day, and in one day there is 24 hours. So now what I actually get to do is just take this. We're going to end up with this over 24, But now we're going to have miles per hour. So I don't need that 24 because I wrote it over here. So on my calculator, I take 2,330,000 divided by 24. And you're going to get 97,083.3 repeating. Now it says to the nearest mile per hour. So I'd probably come back, take off that 0.3, and say mile per hour. And do something like that. On July 7, 2003, that's a date. The rover Opportunity was launched. It landed on Mars on January. I don't like where this is going at all. Assuming that the Opportunity traveled the same distance as Mars' Odyssey spacecraft, how fast did the Opportunity travel? Nearest mile per hour again. So this is familiar because we just did it, so that's good. Along with our formula again. Rate times time equals... Alright, so July 7th. Well, I know July has 31 days. Subtract 7, I need 24. Right? After July, June, July, August. August is another 31 days. I know there's Labor Day. Right? September is actually only 30 days in that month. October, everybody should know that Halloween is there, so you get 30. And then November, that's 30 as well, because we know December has New Year's Eve, so there's 31 days. Don't forget, we go 25 days into January, and this is why I didn't like this problem. Now, that's going to be 202. So when I did this problem, I actually just Googled date calculator. And to be honest with you, if you can figure it out, I am 918 days old. Because I used the date calculator on Google. If you figure out what day this notes video was recorded, I should give you like an extra credit point. But in the meanwhile, this problem, we find out it's 202 days. So it's rate times time equals distance. Right? We're going to end up dividing by our time again. Divide by our time. So our rate is going to equal, it's the same distance. So you're supposed to take the 466 million in the other problem, divided by 202. Your rate is now 230,630.693 miles per day. So then now we're doing our 1 day, and I taught you 24 hours. So if you divide that by 2, alright, your rate is actually going to equal 96122.1. I told you about this point 1. We want nearest mile. You can't see it, but it's the same problem as last one. So miles per hour, which in hindsight, 96,000 miles per hour is pretty fast. So, 2 things to note there. You need to know distance is equal to rate times time. For application problems, you need to know that there is a Google Calendar thingy, calculator thingy, that you can use when they ask for you to find number of days that have passed. There also is a ton of rational expressions that you are supposed to be able to divide and still factor. Let me know if you got any questions. Thank you.